Okay, this is exam 2 for Physics 102, spring 2015. First, a parallel plate capacitor initially has a potential difference of 200 volts, and then it's disconnected but from the charging battery. If the distance between the plates is now doubled, what is the value of the voltage? All right, so a couple things I want to look at here, and that is that Q is equal to C times V, and then also C is equal to epsilon naught A over D. All right. Is disconnected from the battery. That means that whatever charge I have on the battery, that remains constant. And then I want to know what happens to the voltage if I change the capacitance. Now, the distance between the plates is doubled. That means this value goes to twice its original value. So that means that I have half the capacitance. So if I have half the capacitance, what has to happen to the voltage in order to make the charge constant? Well, the voltage has to increase by a factor of 2. So where it was 200, now it needs to be 400 volts. This figure shows a capacitor with plates of area 0.2 meters squared and the distance given here, 1.2 microns. The dielectric constant is 5. What is the capacitance? Well, C is equal to that dielectric constant, epsilon naught A over D. That is equal to kappa, which is 5, times 8.85 times 10 to the minus 12 times the area, which is 0.2, divided by the distance, which is 1.2 times 10 to the minus 6. That gives me I get 7.4 times 10 to the minus 6. That's 7.4 microfarads. The capacitance of a parallel plate capacitor can be increased by which of these? It doesn't change the capacitance to increase the charge. The charge might change by increasing the capacitance, but it doesn't do anything to increase the charge. Likewise, decreasing the charge doesn't do anything. Now remember that C is equal to epsilon naught A over D. So increasing the plate separation, if you increase this, that makes the capacitance go down, so that's not it. If you decrease the plate separation, if this goes down, that means the capacitance goes up, so that's good. Decreasing the plate area, if I make the area go down, that means the capacitance goes down, so that's not one. So the answer then is going to be 4 only, which is A. What is the voltage across this 6 microfarad capacitor? Okay, well the first thing we want to do is find out what is the equivalent capacitance. That's 1 over 3 plus 1 over 6 plus 1 over 2. And that's equal to 1 microfarad. Right, that's 4 twelfths plus 2 twelfths plus 6 twelfths. That's 12 twelfths, which is 1. 1 over 1 is 1. All right, so I have 1 microfarad. And the charge on that 1 microfarad capacitor is C times V. That's 1 microfarad times 18 volts, which is 18 microcoulombs. That means that each of these capacitors has 18 microcoulombs, including the 6 microfarad capacitor. And because it has 18 microcoulombs, I want to know the voltage. V is equal to Q divided by C. That's equal to 18 microcoulombs over 6 microfarads. That's equal to 3 volts. What is the equivalent capacitance of this circuit? Okay, well if I combine these two, that's 1 over 3 plus 1 over 6. That's equal to 2 microfarads. Right, and then I combine this 2 microfarad with this 2 microfarad. That's going to be 4 microfarads. 2 plus 2 equals 4. All right, because these were replaced by a 2 microfarad capacitor. And then I'm left with a battery, a 4 microfarad capacitor, and another 4 microfarad capacitor. And the equivalent of that is going to be 1 over 4 plus 1 over 4. That's 1 over a half, which is equal to 2 microfarads. So B is the right answer for that one. What is the voltage across the 3 microfarad capacitor? All right, so I've already got some of this laid out. If this is 4 and 4, that means I have 6 volts and 6 volts. Those are identical capacitors. They have the same charge. They also will have the same voltage because they're identical capacitors. All right, and I'm looking for the voltage across the 3 microfarad capacitor. Now I know if this is 6 volts, I also have 6 volts here, and I have 6 volts that's shared by these 2 capacitors. All right, so let's think about that. I'm going to clean this up a little bit, get rid of some of this stuff. All right, so I know I have 6 volts here, and then I have 6 volts across these 2. I know that these have an equivalent of 2 microfarads. All right, so that means that on this equivalent capacitor, I have a charge of 12 microcoulombs. Q is equal to C times V. That's 2 times 6. That's 12 microcoulombs. So if I have 12 microcoulombs, that means I also have 12 microcoulombs here and 12 microcoulombs here. All right, and then if I want to know the voltage, that's going to be Q over C. That's 12 over 3, which is equal to 4 volts. So that's my answer. My voltage there is 4 volts. Now an easier way to look at this and say, well, I know that I have 6 volts between these. One of them is twice the capacitance of the other, so one of the voltages will be twice the voltage of the other. And so that means that the voltages one must be twice the other, and they also must add up to equal 6. And the only 2 numbers are 2 and 4, where one is twice that of the other, that adds up to equal 6. And then further, I know that the smaller capacitor has to have the bigger voltage. Q is equal to CV. If C goes down, V goes up, because I know Q has to be constant for capacitors in series. So 4 volts. That would be a quicker and easier way to find that, but you could also go through this method of finding the charge on the equivalent capacitor. So 4 volts is the answer here. Consider this circuit. What is the energy stored on the topmost 2 microfarad capacitor? All right, this one's supposed to be pretty simple. I have 12 volts here because this and this and this are all parallel. They all carry 12 volts. So I have a voltage of 12 and a capacitance of 2, and energy is 1/2 CV squared. That's 1/2 of 2 microfarads times the voltage, which is 12 volts, squared. Half of 2 is 1. 12 squared is 144. That's in microjoules because this unit carries down. So E is the right answer. Current has these basic SI units. Current has a basic SI unit of charge per time. That is coulombs per second. A 10 ohm resistor has a constant current. If 1200 coulombs of charge flows through it in 4 minutes, what is the value of that current? Well, current is equal to charge divided by time. That's 1200 coulombs divided by the time, which is 4 minutes, but 4 minutes is 240 seconds. So 1200, see, that's 120 divided by 24. So that 5 is the right answer for number 9. Which of these statements about the use of voltmeters and ammeters is correct? Okay, well, voltmeters have a large resistance and are connected in parallel. That is correct. Voltmeters have a small resistance. Okay, not correct. They have a large resistance and are connected in parallel. That's true. Ammeters have a large resistance and are connected in series. That's not true. They do not have a large resistance. They are connected in series. Neither of these statements is true. And voltmeters have a small resistance. That's not true. And connected in series. That's not true either. So it looks like this is the only right answer. A flat iron is marked 120 volts, 600 watts. In normal use, the current is, well, this is my power, this is my voltage. P is equal to V times I. I then is equal to P divided by V. That's 600 watts over 120 volts. And so this is our answer. All right. This is one like we've seen before. Current of 20 amps flows through this wire. Which of these is the wire? So we first want to figure out what is the resistance. R is equal to V over I. That's going to be 1.4 over 20. That's 0.07 ohms. And then I know that R is equal to rho L over A. So I can solve this for rho. That's equal to, do 0.07 times the area, which is 7.85 times 10 to the minus 7. Divided by the length, which was 1 meter. And that'll give me the answer. I get 5.5 times 10 to the minus 8. That is the same as for tungsten. So tungsten is the right answer here. All right, for a cylindrical resistor made of ohmic material, the resistance does not depend on which of these. All right, it does depend on the radius of the cylinder, right, because it's dependent upon the area. It does depend upon the length, resistivity, and the cross-sectional area, but the resistance does not depend upon the current. The other way around, actually, the current depends upon the resistance and the voltage. Which of the following best describes the purpose of resistors? They slow the flow of electricity. A battery has an internal resistance of 0.5 ohms. Provides a current of 4 amps. The potential across the battery is 10 volts. What is the ideal electromotive force provided by the battery? All right, well, the observed potential is equal to the electromotive force minus I times that internal resistance. So this would be 10 volts equals to the electromotive force minus 4 amps times 0.5 ohms. That means this is equal to 10 plus 2 or 12 volts. Which of these rules for resistors in series is not correct? Okay, resistors in series have the same current. That is correct. So that's not our answer. Resistors in series must have the same voltage. That's not correct. Let me erase this real quick. This one is not correct. The total voltage across the resistors is equal to the sum across the voltage across the individual resistors. That is correct. And the equivalent resistance is equal to the sum of the individual resistors. That also is correct. So 2 is the only answer. C is the right answer. The only one that's not correct. What is the voltage across R2 in this circuit? Well, I have a 1, a 2, and a 2 ohm. That gives me an equivalent of a 5 ohm resistor. And so I have an equivalent circuit, 10 volts, 5 ohms. This current would be 2 amps, that's 10 over 5. That means I have 2 amps through all of these, in particular R2. So V equals IR, that's going to be 2 times 2 or 4 volts. What is the total current for this circuit? Okay, well, each of these has 18 volts. Right? That means this has 6 amps and this one has 3 amps. So the total current will be the sum of those two, 6 plus 3. The current coming in here has to be 9 amps, and then it splits up into 6 and 3 amps. Or you could say the equivalent resistance is equal to 2. That's 1 over 3 plus 1 over 6. And the total current is V over that equivalent resistance, or 18 over 2. Consider this circuit. The first 3 ohm resistor has a voltage of 6 volts as labeled. What is the voltage across the 6 ohm resistor? Well, first let's figure out what is the equivalent of this. That's 1 over 3 plus 1 over 6 plus 1 over 2. Alright, so that's going to be 1 over 1 or 1 ohm. So I have a circuit here. I have a 3 ohm resistor here and a 1 ohm resistor here. I know too that I have 6 volts here. Now, this I could do this a couple different ways. I could say, well, the current here, well, actually, let me do it this way first. This resistor is 3 times this resistor. So the voltage across this resistor has to be 3 times the voltage across this resistor. So that has to be 2 volts. Or I could say the current here is 6 divided by 3, V over R. That's 2 amps. And so then my current, if I also have 2 amps through that resistor, then V is equal to I times R. That's 2 amps times 1 ohm, which is 2 volts. For the above circuit, what is the equivalent resistance? Well, I have a 3 and a 1 in series, so that's going to be 4 ohms. Consider this circuit. What is the current through the 1 ohm resistor? Let's just first redraw this thing. Looks like this. I have my 2 ohm here, a 1 ohm, a 2 ohm, and a 6 ohm. What I want to know, I want to know the current through that 1 ohm resistor. Let's go ahead and find the equivalent. So if I find the equivalent of this whole thing, that's a 3 here in parallel with a 6, which is a 2. So I get a circuit that looks like this. I get 2 ohms and 2 ohms in series with 12 volts. That means that I'm going to have 6 volts here and 6 volts here. Right, because they're identical capacitors. I could find the current. A 4 ohm resistor, which is that equivalent, is 3 amps. And so that would give me 3 times 2 is 6 for both of those. 6 volts across each of them. Okay, so if I have 6 volts here, that means I also have 6 volts here and 6 volts here across those two. Now, if I have a 1 ohm and a 2 ohm resistor, that's going to be an equivalent of 3 ohms with 6 volts across it. That gives me my current of 6 over 3, or 2 amps. All right, so that means I have 2 amps here and 2 amps here. Okay, if I want to know the current, well, that's the answer. I have 2 amps. All right, I could also look at how the voltages are distributed. I know that I have to have 4 volts here and 2 volts here. And I is V over R, 2 over 1, which is 2. Okay, which of these resistors has the smallest current? My current comes along here. All of the current goes through here. And then the smallest current will go through the branch here that has the largest resistance. And the branch that has the largest resistance is this one. Is that one of our labeled? Yeah, so R2 is the right answer. Which of these statements about a household circuit is true? Right, the household circuit is a series circuit. Not true. All devices in a household circuit operate at the same current. Also not true. As you add more devices, the total current increases. That is true. The ground fault circuit interrupt turns off if IN is greater than that. That is true as well. So 3 and 4. B is correct. On a circuit breaker, you have a 1200 watt heater, a 60 watt bulb, 240 watt radio. When you add a 180 watt blender, the circuit breaker turns off. Assume all the devices operate at 120 volts. Which of these is the maximum allowed current for the breaker? All right, so I know that current is P over V, power over voltage. So for each of these, they have a certain amount of current. This 1200 watt heater has 1200 watts divided by 120 volts. That's equal to 10 amps. So I have 10 amps here. I have 60 over 120, or 0.5 amps here. 240 over 120, or 2 amps here. And then when I add this 180 over 120, let's see, what is that? 4/3 amps. The circuit breaker turns off. Is that right? Yeah, 180 over 20. That's not right. 180 over 120. That's 3 halves, excuse me, 3 halves. amps. So somewhere between 12 and a half and 12 and a half plus 1 and a half, which is, what, 14. Somewhere between the sum of these three and this one, the circuit breaker turns off. So let's see which one that is. That would be the 13 amps it's going to turn off after that. What purpose does a third prong serve? Is B is the right answer. And that's the end.